All right. Looks like it's recording. Anyhow, uh, Physics 11H, the horizontal video, really quick, just a quick talk about the analysis here. We see in this one, both the X and Y position start at 0, like it did, but with the Y position now, similar horizontal position versus time, so nice constant velocity in the X direction, but in the Y direction, we see this curve moving slowly in the Y direction to start off with, and then it gets faster and faster and faster and faster and faster as it falls down. That's gravity pulling it down. So when you look at the velocity versus time graphs down here, right, I'll make these bigger. These are really the more interesting of the two graphs to tell us. They tell us a little more, really. It's easier to see what's going on with the velocity versus time graph. So the x velocity, so here's 0, right? The x velocity stays right about 5.5 meters per second the whole time. All right, slows down a little bit horizontally at the end. Air drag starts to take a little bit of an effect. In the y direction, though, the velocity starts off at 0, close to 0, or above 0, because it gets shot not perfectly horizontally, right? It gets shot a little bit at an angle. So you have an initial velocity that's just a little bit above 0, but then that velocity just immediately starts getting more negative. Again, negative velocity means it's moving down, and because it has a slope, it's getting greater. The velocity is getting greater in the y direction. It's getting greater at a rate of about negative 9.5 meters per second squared, which is close to gravity. All right, so we're going to put that all together and start doing some projectile motion problems. All right, so finish up the lab, get it done, post it, or not post it, fill in the answer sheet and submit it when you're done, okay? In school, obviously, you'll turn it in. Remote kids, you'll submit it electronically.